All right, guys. So this week, towards the end of the week, we're going to be working with some symbolic logic and truth tables. I know we'll get through some of this in class. I'm not sure if we'll get to all of it. So I thought maybe we'd take a look at some of these guys today. Okay, so in symbolic logic, we come up with these compound statements, okay, using the word and or. Okay, and we have a symbol for it. So a conjunction, or what we call a conjunction, is two statements linked together using and a disjunction is two statements linked together using the word or. Okay, so the and, we use an upside down V to represent it. Okay, so we don't have to write out the word and. So this is P and Q. Okay, the or, we use a V. Okay, so P or Q. Okay, and just an example, okay, right here, actually just come up with some statements. Okay, now this is really important down here. A conjunction right here, and, is only true when both of these statements are true. A disjunction, okay, is true if we have at least one of these statements are true. So for instance, this example, this would only be true if Mary plays softball and volleyball. She would have to play both of them for this statement to be true. But right here, Mary only needs to play one or the other. So if she only played softball, that's a true statement. If she only played volleyball, that's a true statement. So and we need both statements to be true for the conjunction to be true, or we need just one statement to be true for the disjunction to be true. Okay, and so I always do this guy to start off with because it gives us an idea of some different things in here, okay, put together, okay, so we can see all these different things, okay, on a regular basis within a truth table. Okay, so we've got all of our four combinations of false and true. Okay, we've done this I don't know how many times, 4 or 5 times. Okay, and so we have our if P then Q. So remember, if P then Q, okay, is false only when we have a true P and a false Q. That's the only way it's false. Otherwise, it's always true. Okay, so that first column we've seen before. All right, now this gives us an and. Okay, so P and Q. So that's a conjunction, and the only way a conjunction is true is if both P and Q are true. So right here, both P and Q are true, so that's true. Right here, they're not both true, so that's false. Here, they're not both true, so that's false. Here, they're not both true, so that's false. Okay, now this guy, okay, is a disjunction. Okay, so remember, a disjunction, you only need one or the other, okay, for it to be true. So P or Q, if we look here, we have at least one is true, so that's true. We have at least one is true, so that's true. We have at least one is true, so that's true. We don't have at least one, so that would be false. Okay? All right, now over here, we're dealing with negations. Okay, so when I negate P, I have to go back to the P column and just change it. So the negation of true is false. The negation of true is false. The negation of false is true. And the negation of false is true. Okay. All right, here we're doing non-Q, so the negation of Q. So I have to go back to this second column where I have Q and negate everything. So the negation of true is false. The negation of false is true. The negation of true is false. And the negation of false is true. Okay. All right, so here I have if non-P, then non-Q. Okay, so I have to use these two guys, okay, because I'm using non-P and non-Q. Okay, so false, false. That's, well, we can go straight down. If we're looking at these two columns, remember the only time A conditional statement is false is if we have true implies false right here. So that's false. Okay, otherwise everything is true. False implies true is true. True implies true is true. Okay. All right, now here we're taking a conjunction. So that's and of non-P and non-Q. So I have to work with these two columns. Remember, the only way a conjunction is true is if both of these are true. So if we look here, that would be false. That would be false. That would be false. And the last one would be true. Okay. Here we're doing a disjunction, so that's or. So once again, I'm working with these two columns, non-P and non-Q. Remember, for a disjunction to be true, I just need at least one. So if we look here, I don't have at least one true, so that's false. Right here, I do have at least one true, so that's true. Right here, I do have at least one true, so that's true. And the last one, I do have at least one true, so that's true. Okay? So I always like to go through this table because we're going to see variations of all of these things, okay, in these truth tables. Okay, so I have a guy like this. All right, so it wants me to do a truth table for this statement. So the last column is that statement, so I'm going to have all the truth values here. Okay, so let's see, we always start with a P and Q, and notice that I'm going to need a or the negation of P or Q. I need that column. So if I'm going to negate P or Q, I need a P or Q column. Okay? All right, so these are all the columns I need. So if we start off with all of our combinations of P and Q, so we have both true, we have true implies false, we have false implies true, and we have false implies false. Okay. So let's see, we have P or Q. So that's a disjunction. So remember, a disjunction is true if we have at least one true. So we look here, we have at least one true, so that's true. We have at least one true, so that's true. We have at least one true, so that's true. We do not have at least one true, so that's false. Okay? Now this column, notice that's the negation of the disjunction. So that's just the negation of this column. So when we negate T, we get false. When we negate T, we get false. When we negate T, we get false. When we negate false, we get true. Okay. Last column, notice this is the conjunction of P, the first column, and the negation of P or Q, this column. So when we do this conjunction, we're using this column here and this column here. And remember, a conjunction is true only if both of these are true. So we look, true and false, that's false. True and false, that's false. False and false, that's false. And false and true, that's false. Okay, so basically in symbolic logic, what this tells us is that this statement is never true. It's always false, no matter what.